I am actually going to go try to get an x-ray on my foot for the afternoon class to make sure nothing's broken. At the risk of taking time to do this, just because I like you guys to be, know about me. I mean, we're in a relationship, obviously. A professional relationship, if you ask me. If you want to know what I'm talking about and why I'm going to disappear this afternoon, come look at this picture. But I will tell you, it is not for the faint of heart. If you get queasy easy, don't come look at this. All right, if you are in the afternoon class and you're dying to see that, just come see me at some point. Because afternoon class, I likely will not be here, and you'll probably just be watching this video on your own. But we got to talk about proportional relationships and equations today. And this is where everything really starts to pull together. Because the 7th grade math class really does flow with a nice progression. And it all comes back to pretty much algebra basics. We do some geometry this year, but a lot of what we do is mainly algebra. So, algebra is anything that uses variable terms, letters, symbols to replace mathematical statements or fill in for things we don't know. That's why we call it a variable, because it could vary. We don't know what it is. So we have this equation right here. Y equals mx. So I want you to highlight, circle something, and then off to the side of that, I want you to also write y equals kx. And that counts. My smartboard's been all goofed up this morning. So I'm going to try to sync it one more time and see if it can fix itself. Now, read through that top intro, or think back to what we did yesterday. Why might we use K or M? What did we talk about yesterday, why we use the M in that equation? We highlighted it in our notes. Andrew?
Because it stands for multiply.
Yeah, it is a multiple that gets my y value by multiplying by the x. Why might I use k? And I'm just showing you this because some different, some state tests or things, they will use the equation in the form y equals kx. Abby, what do you think?
I was going to say, constant, but that would be C.
No, you're absolutely right.
I am.
Yeah. So the reason some places use the K is that's your constant
We should really do that with the C.
of proportionality. Now, here's the reason why they don't use C. Can anyone guess why we wouldn't use C in a mathematical statement? Colin?
It looks like you're multiplying, but you're like, oh my gosh.
It looks like a parentheses.
No, it's fine.
The reason we don't use a C, hardly ever in math, is it looks like a parentheses. So they decided to use the letter K because it's got that same K for constant of proportionality. And really, mathematicians, we don't care how stuff is spelled. I care that I need to solve things. So that K is because of constant of proportionality. So you could highlight or notate that there if you would. So your friend uses the equation y equals 8.5x to calculate the total cost y. So we see that y is going to be my final cost for x movie tickets. So what is our constant of proportionality here? If we just look at the equation, Justin?
Would it be x?
It is not the x. The x is our input value. So here the x will be however many movie tickets we end up buying. That could change. What if another friend shows up? Or what if my parents decide to come? I don't know how many movie tickets I'm going to buy yet, but I do know something else about the situation. Hayden? Y is going to be my final price. Guys, we're asking for the constant of proportionality. Look back at the top thing that we just highlighted. It's the 8.5 because it's the value that multiplies by your x. The constant of proportionality is whatever multiplies by your x. So in this situation, if I am told that cost in total will be 8.5 times the number of tickets, then what is that 8.5 really? Xavier?
The cost per one ticket.
Yeah. So that tells me that one ticket costs $8.50. This is also, I'm really happy that I got a stool this year. This is the first year I've ever like sat down while teaching. But the older I get and the more injured I make myself.
Stop injuring yourself.
I was lamenting in Mrs. Goldring this morning. The worst thing is, and some of you guys have experienced this before, some of you haven't yet, when you do it to yourself, you have nobody to blame but yourself.
Exactly.
Me? Old dude, when you surpass 18, 20, 25, like you start to feel like your body just doesn't work like it used to. I know. Look, I know. I'm not that old. I'm not saying that I am that old, but what I'm worried about is when I'm twice the age I am now. Because think about it, you guys are about like a little under half my age. 12, 13. If you're 13, you're about half my age. So, how much will 13 movie tickets cost? CJ, did you figure this out already?
No, I was gonna ask, so we're gonna get our math test back.
Oh, yeah, I have those to pass back. They're clipped, they're ready. Remind me, I will do that. So let's get through the notes and I'll pass them back. How do I figure out what 13 tickets would cost? Izzy? I set up my equation, y equals the 8.5, but now I plug in 13 for the movie tickets, and guys, I request that you please write this down so you know what we're doing. And that comes out to be
$110.50.
And there are theaters around here that are more expensive than that. There are theaters around here that are cheaper than that. So when you think like, wow, that's expensive. Yeah, if you take a bunch of friends to the movie and just expect your parents to pay, it gets expensive pretty quick. That's why I don't go to the movies.
What?
I just rent it, man. Redbox and Netflix. And I'm an Amazon Prime member, but their streaming isn't as good. But I do Amazon Prime just for buying stuff. Like I gotta buy a new fog machine for our dance Friday. All right, check out the Got It. What do we know about a square? What's one of the main things you know automatically, Colin?
4 equal sides.
4 sides are equal, so we can represent the perimeter by saying 4 times the side length. Because I know that if I have one side length, they'll all match. And instead of adding it 4 times, I can just do 4 times the S. So if it has a side length of 1.6, then to solve, we would just set up that the perimeter will equal 4 times the 1.6.
So 6.4 meters.
And we get 6.4. Check your label. It's meters in the value I input, so it's meters in my output. Any questions so far? Well, it's sorry, it like blinks while it's capturing. I don't understand it, but it just. So now these next 3 get a little tricky. Because when we go back and think about that k, that constant of proportionality, we can look up here that m or that k, and we talked about this yesterday, is really the delta y over the delta x, or we can just say y over x if all we're given is a y value and an x value, and we know it's proportional. If I don't know that it's proportional, I have to use change in y, change in x. So, if I take this equation and I come down here, a certain vegetable dip contains 60 calories per serving. What equation represents the number of calories y? So now it starts to identify calories will be my y value, servings will be my x value. So if I take my information given me, my 60 calories per serving, I know calories is y and servings is x, I got to do my calories divided by my servings to find that m value. Well, when I do calories divided by servings here, that's just 60 divided by 1. Because when it says per serving, That's really per 1 serving. And 60 divided by 1 is just 60. So our equation becomes y equals 60x. Try the next two. I'm going to highlight some important information. Pay attention to what is your y value, what is your x value. By the way, the guessing sheet for the corn kernels, remember you can't open this, I'm trusting you guys. The guessing sheet is right up here. Do not pay attention to anybody else's guesses, because they don't know anything that you know. So when you look at, like, if you think you're going to guess 200, and you walk up there and there's a guess of 500, don't doubt yourself. They could just be totally wrong. So remember, I have no idea how many are in here. I have no bias. I've not made my guess. I've not really thought too much about it. But whenever you would like to, results will be given on Friday at the canteen. But go ahead and put your name and your guess. I believe so. Unless I have wrong information. But... Sorry, man. All right, bring it back. Bring it back. 2 hops this time. All right. So, Kylie, how did you find the M value for this telethon? Yeah, because 60 is my y value, so that's got to go on top. Sorry, my smart board's being real goofy. 60 over 5, you said. That gives you...
calls over hours, and then if you divide them both by 5, then there's 1 hour, and it's 12.
Yeah, so we get 12, which is actually, like Kylie just said, our unit rate, because it's calls per hour. Remember, our constant of proportionality is the unit rate. So this becomes y equals, 12x.
What?
What do you mean what?
Why can't you just write?
What's the confusion? Are you saying like that's not very many? Or did you get the wrong answer?
Wrong answers.
Did you do your division upside down or what?
I didn't do any division.
Ah, so you got, that's why I said you got to check. What's your y value? What's your x value? The only reason up here we didn't have to really divide is my x value was 1. If I have an x value of a number, I got to do division. So, Jack, what do we do in the third one with key machine?
We have to divide the 60 by 12.
Yeah, because now my y is how many keys. So I have 60 divided by 12. What do you get when you do that? 5. So we get y, the number of keys that we can make will be 5 times x, which my x values are minutes. There you go. Any questions on these 3? Izzy? Yeah, so y is your dependent variable. It depends on the constant of proportionality and the input value. So the constant of proportionality stays the same. Once you find it, it stays the same. The input value can change depending on how many hours am I working, how many minutes am I making keys, how many servings of dip am I eating. Like, that's what goes in. Because like if I'm super hungry, I might eat 5 servings of dip. That's going to change my output. Question or no?
It's not really related, but it's a whole canteen during school.
Yes, I believe. Don't quote me, but I'm like 98% certain. Try the got it on your own. Write an equation for y, your total cost. Hey, I should have never talked about the canteen. Show me that you can refocus. Y is the total cost of buying X amount of apples. Y is the total cost of buying X amount of apples. I know, I got a little tight on this page of paper. I try to keep my notes just one page front back, so sometimes it gets a little bit tight. Mainly, if we wanted to figure out our M value, we know that's Y divided by X, but really, we also know it's our unit rate. So in this situation, our unit rate is really going to be the cost per apple. How can we figure out the cost per apple? Abby?
Yes. So, what you would do is it would be 250 over 5.
Ah, so it's my cost. We also know that my Y value that has to go on top is the cost. So it's 250 over 5. What do you get?
I forget. Like, when
So you $2.50
yeah.
for 5 items. What would each item cost?
50 cents.
There we go.
And because that would be the cost per 1 apple.
Yeah, so my equation becomes Y equals 0.50 times X.
Yes.
Because it's 50 cents per apple. It is peak picking season out at Lynn's. If you have never been apple picking, you can beg your parents. The prices change depending on what type of apples, but it was a fun experience. We went a couple weeks ago. Thank you. We're getting into winter. As it gets colder, I will get more stylish. I just don't like being hot, and most of my dress clothes make me hot. When you travel to another, has anyone traveled to a different country, by the way? Sweet. Okay, well, we know a few of you guys. So, have you exchanged money? Have I want real, have you exchanged money? Where'd you go?
Australia.
So what do they use in Australia? Do they use euros there?
They don't use.
A lot of places use euros.
I'm not.
They might have their own currency.
Yeah.
Australia?
Plastics. It's weird.
Yeah, okay. So where'd you go? Oh, well, weird. Yeah. So what does Norway use? Kroner. Do you know what the exchange rate is?
It's like there's no like 1 kroner. Well, yeah, there's. I think it's like.
But that would be like our 1 penny. Like people don't really talk.
I think it's like 9 point something.
Yeah, it's like weird, right? The conversion rate's normally an awkward number. It's some decimal value, some fraction.
Around 9.5 pennies.
Yeah, and it changes. That's the problem. As the value of money changes, the exchange rate changes. So I'm telling you right now, this is probably not current.
It's the other way around. Like
9 cents for a, yeah. Which would make sense, because our penny is a very small amount of currency. Like, it's comparable to, like, the yen. So, if we want to go, trying to make sure that's up there. If we want to go to India, India uses the rupee, not a rupee, a rupee. It is money. Do not think that they're paying people with, like, gems and stuff. It's not. It's money. So, $1. $1 would get you 45 rupees. Hey, Joe, you with me? Because rupees are worth less than $1. So if I am traveling over there, I can either say I'm going to pay $1 and get 45 rupees, or I could use the exchange rate of I will get 45 rupees for every $1. I could set this up either way that I want. So when I go to actually try to solve problems with this, I have to make the choice of which of these am I going to use. So we'll throw that up on the TV and look at our problem.
There we go.
So if we're solving this using that as my constant of proportionality, then my equation would be y equals 45x. Now here's my question. What's the y value and what's the x value here? Is y dollars or is x dollars? Hayden? How do you know that?
Because instead of doing 145, I'm pretty sure you did
45 1. And so x would be 1 because it would be 45 divided by 1.
Yeah. So this is 45 times however many dollars you trade in. Since I know that every dollar gets me 45 rupees, $2 would be 2 times 45. 3 would be 3 times 45. This input is how many dollars I trade in. Because when I head there, I have dollars. So let's say we're going to head to Spain. Now we're going to change our exchange rate.
Oh, you guys are actually going to
Spain uses the euro. It is one of the countries that uses the euro. So if we are traveling to Spain, we walk into the bank, we say, hey, what's the exchange rate? And they hand us a table. I'm like, oh, crap. Other countries like math. That's meant to be a joke. So, it's okay. I don't expect you to laugh. I just want you to know other countries, like most other countries, well-developed countries, are better than us at math. So, like, that's kind of a joke, but it's not really funny.
Oh, not funny.
Why did I circle the relationship that I did? This whole table shares the same relationships. CJ?
It's like easiest, like right when I see that number, I think like 3/4.
When you see 100, you know 100 is fairly easy to work with. And CJ already identified 75 compared to 100. He immediately reduces and thinks 3/4. So we have to answer the question, though, how many euros Y will you get for your X dollars? So I'm going to say the euros that I get will be something times my amount of dollars. Now I have to figure out what that amount is, what that constant proportionality. Now if this input is going to be dollars, we need my constant of proportionality to have a label of something per dollar. Because when we do the per dollar times an amount of dollars, it cancels out, and all you end up with is the other label. So if we want some value per dollar, well, our other value that we have is euros. So our constant of proportionality turns into... Yeah, so we want euros per dollar. And if I get 75 euros for $100, yeah, what it reduces? They can divide by 25 and get 3/4. So my constant of proportionality is 3/4. I did my euros divided by my dollars. Because if I'm inputting dollars, my constant of proportionality has to be per dollar. Whatever other value you have, it's got to be the per dollar. So I set up euros per dollar, euros on top, dollars on bottom. I reduce it. Now I could also make this. Is this what you're about to say? No. I could also make that a decimal and do 0.75 if I wanted to. But that doesn't change anything. Question, Hayden?
This is weird. You're giving them $100, but yet you're only giving 75 back.
But it's not dollars anymore. So that's like when you give somebody $50 or $60 and you get 1 back, but your 1 is a game. Or like what, you know what I mean? You're used to exchanging money for goods. This is just money for money, but it's different money. Justin?
Can't you do euros divided by US dollars? The same thing.
That's what we did.
Oh.
So if I was going the other way around, if I wanted to know how many dollars will I get for a certain amount of euros, then I'd have to flip this and do dollars per euro, because I'd want to know how many dollars I get per every euro that I give. But since we have dollars, we did euros per dollar. But this could change with whatever you have. It's just my input is dollars, so I have to have per dollar. CJ?
Did you find that missing calculator?
No, I'm actually missing, well, I'm missing 2 total, but 1 was already missing over the summer. So I'm like, there's 1 actively missing right now. So it's okay. It's probably in somebody's locker or something. Or stuck under a desk. Like, some of you guys, and I'm hoping it's nobody in this room, but some middle schoolers are very irresponsible and they don't take responsibility for things they get out or things they use. So then, like, last year we had a big issue with people, like, stashing stuff in my cupboard, like, shelves over there. They would just, like, they'd be done with it and, like, shove it in there. I'm like, what the heck, guys?
What?
So,
I will.
now you're coming back from Spain. Hey, Anthony, do you need to move or can you handle sitting next to Hayden? Because every time I look over there, I'm shooting eyeballs that say shut up, but you're not getting it. So can you sit there or do you need to move? Okay. You are now coming back from your trip. Now you have euros in your pocket. You want to go to the bank and get dollars back. So you want to know, how many dollars will I get for my euros? So the question now, I want the constant of proportionality that I'm looking for is going to be dollars per euro. So now I set this up the other way around, and it's 100 divided by 75 if I use this one again. Which, huh?
Would my answer be right for this one?
Is it 4/3? Or 1.33 repeating forever, or 1 1/3, or...
Oh, that's mine. 1.33.
So, I would not change this to decimal form. If your decimal form is a repeating decimal, I would not change it to decimal form. I would leave it as a fraction. Because now, my equation becomes the y, the amount of dollars. Because pay attention to what they did, guys. They switched your x and your y. Up there, y was euros. Down here, y is dollars. Up there, x was dollars. Down here, x is euros. So they flipped your x and your y, which is why my constant of proportionality has to flip. So now I get the equation y equals 4/3 times x. Because my euros are my input, my dollars are going to be my output. Any questions on how we set this up? Yeah, and really we know that our constant of proportionality has to be the y over the x. And when we're told y is dollars, x is euros, I know that dollars has to be divided by euros. So if you remember this equation, that to find your constant of proportionality, it's your y divided by your x, that will serve you well. Always remember it's y divided by x. And if you care, that turns into the slope. When we graph lines, that constant of proportionality, this 4/3 right here, will be the slope of the line. We're not there yet, but when we get there, then you'll think back and be like, oh, yeah, I remember you saying that, and then it will seem easy. Hopefully. Oh, no! Well, I cleared that without writing it down. But quickly, we really ended up with y equals 4/3 times x, because m is y over x, and that's 100 over 75. All right, sorry, I wanted to get that captured. Any questions up to here? Now, let's say I have a weird relationship where I'm told values for each of these. Now, your body is pretty awesome. Like, when I think about, like, the hole in my toe, it makes me cringe, but I know that my body's actively working to fix myself, which is great because I don't know how else I would fix myself. So, one cool thing about our bodies is it's a lot of water. When we think about the earth, and actually if we think about the earth and us, like the earth is a lot of water. We are a lot of water. So for every 5 pounds that you weigh, approximately 3 pounds of it is water. Now it's slightly different for you because you're a kid, but with adult males, like myself, every 5 pounds of your weight is 3 pounds of water. So there's only 2 pounds of other stuff, like bones and the other things that aren't necessarily water, like hair, that sort of stuff. But 3 out of the 5 is water. So we could then set up for a 188-pound person that they'll have 3 pounds of water for every 5 pounds total. How much water weight do they have if they weigh a total of 188? So I can just set up this proportion because I know that I have water on top, total on bottom, water on top, total on bottom. Any questions with how I can set up the proportion, like step 1 right here?
Wait.
Is that wait a question or wait you just want to talk? So then, I have multiple ways to solve this. Off to the side here, I would like you to show the cross multiplication method. If I have a fraction equal to a fraction, which a lot of you have been trying to use this incorrectly, I can cross multiply, and I get 3 times 188 will be equal to my other cross products, which are going to be 5 times w. I'm now going to change to a neutral color of green. So 3 times 188. Thank you. Didn't realize you guys were going to be quick. Equal to 5w. Now I need to solve for the w. So, dude, what's funny is I hate this. Mr. McCauley, I'm going to email you this video. So I had a high school math teacher that I would laugh at because he would do just that. I would tell him what I got on my calculator, and he would write the wrong thing, and then we'd all like snicker, and then he'd say the number and write the wrong thing. It was hilarious. And now it's happening to me, and it's not so funny. So, what do I need to do to get the w by itself? What do I need to get rid of? Shane, what do I got to get rid of? The 5, right? The 5 is attached to my w. How? Multiplication. What undoes multiplication? Division. So we on each side divide by 5. W is going to be 1, 10, 12, 1, 12.8, I think. And that would be pounds of water. So in a 188-pound person, they have 112.8 pounds of water. So wrestlers, and this gets dangerous, wrestlers know that, and if they're trying to make weight and drop weight or gain weight dramatically quickly, they use the water weight to their advantage. I had a buddy who used to wrap himself in trash bags and sweatpants and stuff, and he'd go run like that. So if you put on sweats and then you put on trash bags, you can't release your body heat, and it gets trapped in, and he would just sweat like buckets. When he would take his stuff out, he could wring out his clothes, but he would drop weight. Dangerous thing is then he got to States. He was a great wrestler. Buddy's name is Ben. He still lives in Coshocton. Got to States, but because he had dropped so much weight from water, he weighed in. He made weight. He was in the right weight class. Then he passed out because he was so dehydrated. They wouldn't let him wrestle. He couldn't wrestle in States because to make weight, he'd gotten himself so dehydrated, he ended up passing out. Now he passed out and they're like, Ben, come back and he came right back. But because he was so dehydrated, they wouldn't let him wrestle. So it's that tough, you gotta know where your body balance is. The other way to solve this is working through to cancel out the division of 188 by multiplying by 188, because really, this is like 188 over 1, and these can cross-cancel, and then I can do the multiplication. But notice that we get the same answer either way. So, I like cross-multiplication, because it always works. And it's nice and handy, because it always works. How you solve it is up to you. So, if in a certain soccer league, if you didn't know this, Mr. Sherg loves soccer. I do as well. I just don't get to play very often. You have a ratio of 2 goalies for every 30 team members, which is about accurate. You'd probably have 2 goalies on a team. So if I set up my goalies over total team members, then I'm going to have 2 over 30. And if I get told that in the league there are 915 players, and we're trying to figure out how many goalies are there, like let's say we're trying to buy jerseys or something, where would my 915 go? Where in this proportion would my 915 go? Ooh, now I got some hands up. Andrew?
It would go at the bottom
Why?
because it is the number of players on the team.
Yeah, this is not the number of goalies. It's the total players in the league. My denominator is total players. So we set up over 915. And I'm just going to use G for goalie because I don't know it. I set up cross multiplication. 30 times G will equal 2 times 915. Do not skip steps. So 30G will now equal 1830. Julia, how do I get rid of that 30 in order to get G by itself? So back up and ask yourself, how is it attached? Yeah, so it's multiplied, right?
Yeah.
What's the inverse operation to multiplication?
Division.
Division. So we want to divide, and to get rid of 30, what should we divide by?
Is it 2? I don't remember which one it is. Okay.
Help her out.
Divide by 30.
We want to divide by itself, because then this really turns into 1G, and I don't need the 1, so we just say that it's just G. When I divide by 30 over here, 61. So I knew that 18 divided by 3 would give me a 6, and a little bit of work with the zeros. 30 divided by 30 would give me 1. So I know that there are 61 goalies in the league. Any questions on that problem? Solve the got it for the defensive players to total players. We have 9 defensive out of that total team of 30. If we have 9 defensive, a total of 30, solve for the total defensive players. Please stay with a hand if you are confused at all. I can help you. Says what? Huh.
Oh yeah, I saw that.
You should change hate to love. Then it will be like a positive desk. Sit down. Oh, I love you too.
There's this one desk
Thank you,
inside.
guys.
This is like everything, and I'm just like, oh my gosh, everybody wrote on it.
You know what that shows me? Somebody didn't want to care about their academics, which probably meant they had a lack of confidence.
Haters back off.
Hmm?
I don't know what they wrote. I just read it.
Yep.
'Cause it was
All right, so I've set up the ratio that I know, except I set it up in the wrong place. We've already talked. We've talked. Casey. Yeah, I was just scanning the room. She's not here today. Atticus. Where do I put my 890? So, just right here, under. Then, what do? If you don't overthink it, the next step's actually really easy. I introduce a variable. I don't know what that is, so I just give it some letter. Try to use letters that don't look like numbers to avoid confusion. Justin, what do I do now?
Okay, so now we're gonna cross multiply.
Yeah. So I get 30 times D equals 890 times 9.
That's 7,000.
What'd you get?
7,560.
That's equal to the 30D. 30D. It's hard to say.
Wait.
Is this multiplication not right?
Yeah, I think it's 8,010.
Yeah, it's 8,010.
8,010.
Oh, I'm gonna snicker.
All right, okay. Can I get verification this is 8,010?
Yeah,
Yes.
I have
Okay.
a calculator.
So, in case I'm getting blocked for you people watching out there in the cyber world, we have 30D equals 8,010. Now, Bella, do you know what I can do to get the D by itself? By? Yeah, we divide by the number that's attached to our variable. So we divide by 30, and this gives me 267. So this is not that problem. I just moved it so that anyone watching the video. Then, the last thing to discuss, how would we solve this proportion in the got it?
Cross.
Yeah, cross multiply, divide to solve. So that's all I got for you guys. I'm going to go ahead and solve this final problem, so if you really want to see it, you can go check the video later. Huh? Ah, crap. So I'll solve this problem here in a minute once you guys are on it. Alright guys, so the last problem here, if you're sticking around for it, we have this proportion at the bottom of the screen. How would I solve 19 over x equal to 152 over 4? So any proportion, I can always cross multiply. I could start by checking, is there an easy multiplication? I don't even want to waste my time trying to think about that because 19 and 152 seem very awkward with each other. So I'm going to cross multiply. Just slide this stuff over actually. So I'm going to get 19 times 4 will be equal to my other cross multiplication of 152 times the x. My 19 times 4 is 76. Come on. And then I still have the 152x. To get rid of the x value, or sorry, to get the x value by itself, I gotta get rid of the 152. So we then divide by the 152 on both sides. And we get 76 divided by 152. X comes out to be 0.5, or it is just a half. If you guys have any more questions, please let me know. Put a comment on Schoology, send me a message, anything like that. But aside from that, try your homework, and then we will take questions in class tomorrow. Thank you very much.